thermostat's almost at 85. I'm pretty sure just being ignored. How'd you feel about the test last week?
I felt pretty good about it.
I don't remember your score or anything, but
I got a 95 with the curve.
pretty good. So that probably means you missed maybe 2 or 3 points. Calculus harder than you expected, or about the same?
It's about the same. Actually, it's a bit easier than I expected, but I don't know.
Even all those like long algebra, common denominators, weird GCFs.
It's time consuming. It's not like super difficult though. Also, I am putting a lot more work into this class than I have in the past to other classes, so that might have something to do with it.
Yeah, well, I mean, if you don't put more time into calculus, it's just too hard. Like, you can understand the concepts, but like getting the answers right without practice, it's just not going to happen very often. I didn't take calculus until college, but I think I spent probably like 3 hours a night on calculus.
I don't spend that much time.
Yeah. Well, in high school, in college, like I probably went to classes probably only twice a week, so they give you more homework. Whereas y'all are in here like 2 to 3 times for a longer time, so you have more in-class time to practice and stuff.
Good, how are you?
I'm great. Yourself?
I'm pretty good. 3-day weekend is much needed.
Me too. Me too.
Alright. welcome back. Okay, last time I saw you guys, we had finished up Unit 3, and so we are moving on to another unit. And so I'd like to maybe give just a 1 minute kind of overview of what we've got left this semester, just to mentally start to prepare. Plus, this semester is going to end before you know it. We've got about 4 weeks, or I think it is exactly 4 weeks till Thanksgiving break, and then when you come back, it's like 2 full weeks, 2 days, and then finals. So, semester will end pretty quickly. So, we're moving into Unit 4, and in Unit 4, we do a lot of graphical stuff. We're going to do the first derivative test, second derivative test, extreme value theorem, and mean value theorem. That's what's going to make up Unit 4. All of that stuff will carry over into Unit 5, which is what we call curve sketching, which is a bigger emphasis on graphing, but it's a lot of the same skills. So we'll have a test over Unit 4, we'll have a test over curve sketching, and then usually we do a couple topics, 2 or 3, just like 1 day topics, before we look at semester test stuff. So, few days on Unit 4, extreme value theorem, mean value theorem, first derivative test, second derivative test. Take a test, do curve sketching, which is almost the same stuff, but all graphical. Take a test, 1 or 2 more lessons, and then we'll move on to semester test review. So what we're going to look at today is the first derivative test. So one of the handouts y'all picked up should be 49. So we're going to do this first, and then I've got a book assignment that's short, like 11 or 12 questions, and I'll give you some class time to work on that. But once it looks like the majority of the people are finished with that, we will move on and start to take notes over extreme value theorem and mean value theorem. Okay, so first derivative test. There's a few new terms in here, and I don't know. A lot of this is going to sound kind of familiar to you, though, which is good. You're getting more familiar with derivatives. But for the first derivative test, we need to, it's called the first derivative test because we're talking about the first derivative a lot. If the first derivative is positive, what does that tell you about the function? What's that? Increasing, okay. So basically positive slope means the graph's going up. So negative derivative means the graph is going down. So again, even though I'm telling you this like it's the first time you've heard it, here's another one back there. That one's not working. It should be kind of intuitive. Derivative means slope. Slope's positive, your graph's going up. Your slope's negative, it's going down. Okay, if the first derivative is 0, then f at that instant is constant. At that moment, it's flat. So, if it helps, draw a little picture over here. Positive slope, negative slope, or when the derivative equals 0. Okay, so we're going to start to use this term a lot. There's something called critical numbers that show up a lot with the first derivative. Critical numbers and critical points, very similar ideas, but critical numbers occur when the first derivative equals 0 or is undefined. Now, 90% of the time it's when it equals 0, but occasionally it's when it's undefined. So I'm going to always say both of them, but the reason why I say all of them, or both of these, every time, is to try to emphasize this one. Okay, so what makes critical numbers important is that they are often, critical numbers often are going to give you an extrema. So remember, extrema just means like a relative max or a relative min. Like if you're looking at a small set of data, it's the biggest value or the smallest value. So this is a very, very simplified function, but I tried to pick out one that we should know what it looks like. X cubed looks like this. But if you had a question to find the critical numbers or to find the points, you would need to know number 4 here, and you'd have to know that critical numbers come when the first derivative is 0 or undefined. So you would take the first derivative. If you had x's in any denominator, you would need to figure out what numbers make those divide by 0, because those would be undefined. Otherwise, you need to figure out what numbers make the first derivative 0. For this one, it would be x equals 0. But I use this as an example to show you that just because it's a critical number does not mean it's an extrema. Extremas are like this. Extremas are either a relative max or a relative min. So just because the derivative there for a moment was 0, it didn't end up being a max or a min. So don't make that assumption, even though that's what usually happens. All right, what the first derivative test technically says, if you're trying to find local maxes or local mins, relative extrema, this could happen when the derivative changes from being positive, so the graph's going up, to the first derivative being negative, which means it's going down. Because if your graph was going up and then it's going down, in between there's probably a relative max. So, or a local max. Local max and relative max, same thing. I try to use those interchangeable. So, same thing with this. If I asked you where are the critical numbers, the parts you have to have memorized is that critical numbers occur when the first derivative is 0 or undefined. So you have to take the first derivative, algebraically solve to where it's undefined or where it's equal to 0. And this gives you a critical number. And there can be more than one of them. I don't have this printed out anywhere on your notes, so you probably should write this. If your critical number ends up being a point on the graph, then we can call it a critical point. Critical number just means that it makes the first derivative 0 or undefined. But if that's not really a point on the function, like if x equals 0 isn't really a part of this function, we can't call it a critical point. It can't be a point if it's not a point on the graph. So again, these are very easy to mix up. Critical number versus critical point. That's not real important today, but
I have a question.
yeah.
Could you read out the sentence?
Critical number is a point on the graph. If the critical number is a point on the graph, then we can call it a critical point.
Okay, thank you.
To be a point on the graph, to be a critical point, it has to be a point on the graph. Some x values just don't exist. So, okay, so I picked out this one because this is hopefully one you know how to graph. This looks like x squared flipped over the x-axis and then shifted up 7. Again, a pretty basic function. They're not always going to be that basic. But when I found this critical number, this tells me this is the only place there might be a relative max or relative min. So since we know what this looks like, we can visualize it and we can see it. It's a relative max. But what the work you normally need to do, because you don't normally know what this graph looks like, nor are you allowed a calculator. So we have to start making these, what are called, most people call these sign charts, although I make it a little bit more detailed. So you need to put this on your notes because this is good for FRQs. Doing this work, I figured out that x equals 0 is a critical number. And again, if I just didn't know anything about what this function looks like, I can still use the first derivative. So this is the only place where the function might change directions. It's not a guarantee. We saw right here, a critical number, it did not change directions. It stayed increasing the whole time. But what you need to test is you need to see what's happening somewhere to the left of this. So you can pick the number negative 1,000 if you want to, but negative 1 is probably going to be easier. And more specifically, I want to plug negative 1 into the first derivative. Because when I do that, I get negative 2 times negative 1, which is positive 2. And what do I know about the function if the derivative is positive? It's increasing. And I don't have to test all of these other numbers. If it's increasing at negative 1, and the critical number is the only place it might be changing directions, then all of these values are increasing. So if you'd rather do negative 2 or negative 5 or negative 10 or negative 1,000, you can, but the first derivative is positive. Then you've got to test on this side of the critical number. So maybe try 1. If I plug 1 into the first derivative, do you see how it's negative? If I plug 1 into the first derivative, we get a negative value. Okay, and if the first derivative is negative, what does that tell me about the function? It's decreasing. And so this visual, not only is this good for getting points on FRQs that avoid you writing a detailed paragraph explanation, it gives you a little bit of a visual of what this graph looks like. I know it was increasing to 0, and then it was decreasing after 0. So this tells me, just from this little visual, that this is a relative or local, whatever you want to call it, max. So notice over here, we know exactly what this graph looks like. Same thing. Positive derivatives, 0, negative derivatives. I know it was increasing till 0 and then decreasing after 0. The same little sign chart does the same stuff. But critical numbers are important because this is the only place that might be changing directions. We actually have to plug in numbers into the derivative to know if it's going up or down. Okay, the other possibility, number 2, is if your derivative changes from negative to positive. So if the first derivative is negative, the function is going down. And if the first derivative is positive, it's going up. And if it switches from decreasing to increasing, then there's a moment in there where you have a local or relative minimum. So again, oversimplified question here, but x squared plus 5 is going to look like x squared shifted up 5. But again, normally you don't know what the function is going to look like, so we can't just answer it based on this. If you had a test question saying find the extrema or find the local mins, you would need to know that they're going to possibly occur at critical numbers. And critical numbers occur when the first derivative is 0 or undefined. So we've got to take the first derivative, solve to see where it's undefined, solve to see where it equals 0. And critical numbers are the only place the graph might be changing direction. So since I know what this graph looks like, I can see that it actually does. How we can figure out if this is a max or a min or neither with calculus is we have to do this sign chart. We can say x equals 0 is a critical number, so it might be changing directions there. We're going to throw in a number to the right of that into the first derivative and a number to the left of that into the first derivative. It doesn't have to be 1 and negative 1, but you should pick numbers that are easy. If you plug in a number into the first derivative and you get something positive, it means it's increasing there. And if you plug a number into the first derivative and it's negative, it means it's decreasing there. And this little sign chart, even though this is not trying to be an accurate graph, it shows me the direction of the graph. It's decreasing till 0, then it's increasing after 0. So with this visual down and then up, this tells me that x equals 0 is a relative min. So the only way that the first derivative test gets any harder is if the function's harder to take the first derivative of, maybe harder algebra to solve for 0 or undefined. That's about the only ways it gets harder, but very similar questions from question to question. Yeah, what you got, Grace?
So for an FRQ, which one would be? Could you use either one to draw as an explanation with either graph?
Well, the problem is most of our functions we look at are not going to be stuff that you know how to graph without a calculator.
Okay.
I'm just graphing it real quick so that you can say, you know, we know what this looks like, or I think you should know what this looks like. And I'm just trying to relate it to what the calculus does.
Okay.
But sure, if this was an actual function and you know what this looks like, you could answer it without calculus. Okay, if f prime does not change signs, so if it goes from positive to positive or negative to negative, then it has neither a local min nor a local max. A min is when your graph goes from decreasing to increasing. A local max occurs when it goes from increasing to decreasing. And if it's increasing to increasing or decreasing to decreasing, it's not changing directions, and you don't get either of those. Okay, so let's practice a couple of these together, and then I have you practice a couple of them quickly out of the book assignment. I went ahead and typed this up, even though this is something you guys will get sick of me saying, but this will impact your grades on FRQs in this class. When you do FRQs, you can't say things like it increases, it decreases, it goes up, it goes down, it changes direction. You can't use the word it. You need to say what you're talking about. If you think the function's increasing, say the function's increasing. If you think the graph is positive, say the graph of whatever is positive. If you use the word it, even if you're correct, nobody can assume that you're talking about the correct thing. So as that comes up, I will keep referring to that. Okay, but let's say we wanted to find the local extreme points of this graph. Now again, I don't know what this graph looks like. This would not be a calculator question, but I'm interested in where the local maxes and the local mins are. So I can find critical numbers by figuring out where the first derivative is 0 or undefined. So that requires us to take a derivative, be able to algebraically solve it for where it's undefined. That's only going to occur if you have an x in the denominator, or where it equals 0. Of course, the algebra can vary in how difficult this is to solve, but this one could be a GCF and the difference of two squares. So 2, -2, and 0 doesn't equal 3. So there's two critical numbers here. So our work, our kind of map to visualize what this graph looks like without graphing it, is we need to make this line chart, and -2 is supposed to be a critical number. So label that under there. +2 is a critical number. Critical numbers are the only place that the graph might change direction. So if I want to know whether it's increasing or decreasing in this part of the graph, what do you think we should do? Okay, so if I'm interested in a point, the original equation, but if I'm interested in slope, I want to plug into the derivative. So we could pick any number between -2 and 2. I know it's not going to change direction between these, so I'm going to pick out something easy like 0. And I need to show that I'm plugging in that into the first derivative. So if I do that, I get -12. I honestly could care less that it's -12. I really only care that it's negative. So we make a little line that looks like he's going down to represent that it's going down between those values. So at x equals 2, is this a relative min, relative max, or do we know yet? We don't know yet, because it could still be going down. So you have to also plug in a number to the right. You have to plug in a number to the left and right of every critical number. If I plug in a 3, I don't know what this comes out to be, but I know it comes out to be something positive. So the graph's going up. Same idea, you got to go over here and maybe plug in -3. But we're interested in the slope, the direction of the graph. So I'm plugging into the derivative, not into the function. If I plug in -3, is that going to be positive or negative? Because if you square it, this becomes positive and that's bigger. So this line chart is a very quick way to visualize, hey, it was going up and then it's going down. So at x equals 2, there's a relative max. And then it was going down and then it was going up. So at x equals 2, there's a relative min. Now, if you needed the full coordinate, you would have to plug in x equals 2 into the function and solve for y, or plug in x equals -2 into the function and solve for y. But this tells you when and how you can know. So basically, it takes a little bit of practice to do this line chart to give a quick little visual of what the graph looks like. We don't care how far up it's going or how far down it's going, just about whether the direction's changing or not. So that's why I feel like there's not too much new there. Okay, is this the last one, number 5? Okay, so let's look at one that's a little bit harder, and just that the function's a little messier. The thought process is all going to be the same though. So if I want to know where the local maxes or mins are, the local extrema, I know that those can only occur at critical numbers. Not all critical numbers are extrema, but all extrema occur at critical numbers. So you have to know that critical numbers come from when the first derivative is 0 or undefined. So you've got to be able to still do power rule, and chain rule, product rule, quotient rule. All of that stuff is still fair game, although it does come up a lot less. You've been doing a lot of that stuff to make sure that you can do it, but most of the time it's power rule and chain rule. Okay, so you've got to be able to take the first derivative. For this to equal 0, this would be when the numerator equals 0. And to figure out where it's undefined, that would be where the denominator equals 0. Division by 0 is how you get undefined. So we could divide both sides by 3, we could cube both sides, factor, and it looks like 3, -3. So this function has 3 critical numbers. But you have to understand, and even on your AP exam, you'll probably have a question that just says find the critical numbers. Like they'll ask you to do that. But most of the time, you need to know what these are useful for. These are the places it might be changing directions. So when we do our line chart, we're going to have to test around 0, -3, and +3. Those are the only places it might be changing direction. And you need to label that these are critical numbers. To know what it's doing between 0 and 3, you need to pick a number in between those, like maybe 1, and plug it into the derivative. I don't really care what the point is, I just care if the slope's positive or negative. So if I plug 1 in up here, I get a positive over a negative. Positive divided by a negative is negative. To know what's going on between -3 and 0, I need to plug in a number between those into the first derivative. That would give me a negative over a negative, which is positive. Now, to get the actual numerical value, I'd have to be a little more careful and slow down. But okay, and then I also have to test outside of these. So maybe try like 4. That would be a positive over a positive, which is positive. And I don't know, maybe negative 4. You could do negative 10 if you'd rather. It's just that the bigger numbers you pick, probably the harder it's going to be. Plugging in negative 4 would give me a negative over a positive, so that comes out to be negative. So, I don't know exactly what this graph looks like, but with this sign chart, I can tell you quickly which direction the graph's going. It's going down, then up, then down, then up. So right here, if it was going down and then back up, if it's switching from decreasing to increasing, then right here is a local or relative min. Same over here. And then right here, it was going up, it's increasing, and then it started to decrease. So at x equals 0, we've got a local or relative max. Same thing that you did in Algebra 2, but in Algebra 2, you always had a graph or you had a calculator, and you just described when your graph was going up or down. Now we can do this with calculus, because if your derivative is positive, it's going up. If your derivative is negative, it's going down. So just a different way to work stuff that you've done in the past. Okay, any immediate questions you want clarification on before you practice a few of these? Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there's 11 questions total out of the book. So I'd like you to go ahead and start on those, and I'll come around the room. And when it looks like at least half of the class is finished with the book work, we will move on to 51. So if you work a little bit slower, that's fine, but you may have to finish up some of the book work for homework. Again, once it seems like the majority of the class is finished with the book assignment, that's when we'll move on. So if you don't want to do any of the book assignment for homework, you need to be in the quicker half this morning.
So when it gets to this, you know how our room said that this is correct. Is that a 0 equal that?
Oh, no, that was that. You have to set every factor equal to 0. Set this equal to 0 himself, set this equal to 0, and you also need to set this equal to 0. But 3 doesn't equal 0, so I was saying x is like, it doesn't give you anything.
Okay, so I don't put that as correct. Okay.
But if this was 2x,
Well,
you
yeah,
would need
obviously.
0. Yeah, but sometimes I'll do that, so.
So I put the 3 in, and then I go for
3, say that it's a critical number, you can just put C in. You need to show what number you're plugging into the first derivative. There you go, like that.
Right, yeah,
Plug in.
4 and 2.
If you plug in 2, that would be 4 minus 6, which would be negative.
Okay. And it's, yeah, okay, I get that.
Assuming your first derivative is correct, I don't know.
Yeah, it's x squared minus 6x. That's it.
Okay, so this, it looks like there's a relative min of x equals 3. The graph's going down until 3 and then up after 3. And on this one, they're giving you the picture that's going down till 3 and up after 3.
So I'm just confirming that that's right.
Yes, because normally you don't have to graph it.
Okay, so I just put yes? And then relative min?
No, they want to know when is the function increasing and decreasing. So you should say increasing from 3 to infinity and decreasing from negative infinity to 3.
How do you write that again? The,
Do INC is fine.
oh, I meant like, is it
Parentheses.
parentheses? Okay,
For increasing, decreasing, and constant, you can just always use parentheses. If you're doing domain and range,
DEC,
that's fine. But you can't decrease from infinity to 3. It's always left to right. You mean negative infinity to 3. Decreasing from here to here. From negative infinity to 3. It's decreasing from negative infinity to 3.
That's what I put there.
You have positive infinity.
That's a negative.
Oh, I don't see your negative.
Sorry, I'll make it up here. You really confused me.
Yep, let's do it fine.
So you want to say?
Answer it like this, like.
I want,
Yeah.
well, the picture is just to help check your work. Don't get the answer just from the picture.
No.
So find the critical numbers, do the line chart, and then if you don't have that it
It's just
decreases
confirming that that's right.
from negative infinity to 3 and increases from 3 to infinity, then I need to look at your calculus.
The derivative of the.
You guys need to notice that the first couple here, they give you the graph too, so that's just to help confirm that your calculus is matching up with what the graph really looks like. Normally, you don't have the graph in front of you.
Yeah. Oh, yeah, you shouldn't be putting anything on this one. This one should always. You did this, you did. No, oh, I'm over here.
So I sent you an email.
What'd you get 3 from over here?
Yeah, I saw
How did you get critical number 3 from that?
They've already done it. This is where it changes.
Yeah, but you're not supposed to go over that.
When the deadline goes, but I know it's saying, so.
Oh, okay. Yeah, you gotta find the derivative.
So this is just the answer, 6 and stuff?
Well, it wants you to actually say that it's decreasing from negative infinity to 0. That doesn't look right
Yeah,
there. Why does that say x equals 0?
Decreasing, I'm pretty sure.
Oh, at x equals 3.
Yeah, it should be x equals 3.
But how did I get that from here?
Because you just, your minus 6 just disappeared.
Oh.
That should be 3. So they want you to say it's decreasing from negative infinity to 3 and increasing from 3 to infinity.
So they want me to write that out?
I mean, you just say, you don't have to like write a long explanation or anything, but you can say increasing from 3 forever right and decreasing forever left 3.
You're saying, yeah,
Okay, got it.
you're saying 3x squared over 4.
Okay, anybody still stuck on number 3? Okay, anybody stuck on number 5?
3x squared times 12 is 3. You're just confirming the graph. Don't go off the graph. Yeah. Then pretend the graph's not there. Yeah. Where do you advance level?
Alright, so what you do is function x cubed over 4. The quotient rule. You find remove that.
Yeah.
Right. It's just quotient. Just quotient. You find remove x cubed over 4.
Quotient.
So remove x cubed minus x cubed over 3.4. So minus 0 doesn't matter. All you need is remove x cubed times 4. The denominator square. Over square.
I need to write out that. Why? It does the same thing.
Just remove x cubed over 4 minus 3 plus 1.
So it's just x cubed over 4.
Just quotient rule.
No.
Watch.
You need to say which part's decreasing and which part's increasing. No, just like how I did it there. Increasing from 3 to infinity, decreasing.
Minus 3x. We're doing a quotient.
Yeah.
Quotient x cubed over 4 times your infinity, which is 3 squared. Times this left alone. Times that left alone. Minus, minus. Got the first. This whole thing x cubed times derivative of that. Derivative of 4 is 0. This whole thing is 0. We can ignore all of this. So now we have this over the denominator square. So it's quotient 4 times 4 over 16. 12x squared over 60.
Oh, it's just
Pretty simple. I'm going to simplify to x squared over 4.
But you're saying to forget the first one?
No, I was just saying, so now that we have, we just look at the minus 3x. That's just minus 3.
Oh, okay.
So it's just 3x squared over 4 minus 3.
And then, yeah,
Keep going.
oh, that's why it's up, yeah.
Okay. No.
You're gonna have to get a common denominator to add those together. But then if you can make it one big fraction, then it'll equal zero.
Zero, zero, zero.
And it's three on the denominator. And what is this denominator? Okay. And this one is the square root of 16 minus x squared cubed.
And it does match it, yes.
Then you need to multiply the top and the bottom of this by that
The instruction
denominator.
is use the graph.
So make sure that's correct. I would maybe double check the word for
Do your next quotient will be
You'll still use product and quotient privilege, just it'll be like once a class instead of 5 times a class.
Okay.
So for this one, should I have not factored out x plus 1?
Number is 7? Yes. I just don't know. Okay, so. Okay, your derivative looks fine.
Okay. When I said it equals 0, negative 2 does not equal 0.
Okay. The critical numbers don't just occur when the first root equals 0,
And it's undefined.
also when it's undefined. So it's going to equal 0 when the numerator equals 0. It'll be undefined when the denominator equals 0.
Oh, yeah. Okay, so I need to set the denominator equals 0.
It's defined the other critical numbers.
Okay, so if I come up with something like this, I just use the denominator.
For undefined.
Okay, and then the denominator.
When you try to divide by zeros, when you get undefined.
Okay.
Also on this, the way you did this was perfectly fine. Looks like you did quotient rule. But you could also have you could have rewritten this as x plus 1 to the negative 2.
Mm-hmm.
And then we could have brought the power down, lowered the power by 1, and you end up with the same thing.
Okay.
So what you did is not wrong, it's just a little more work.
Okay. Thank you.
So of course you guys are having to get used to the line chart and what a critical number is, and thinking a little bit deeper about whether it's going up or down based on the derivative. But hopefully you guys look at your work and think that this is a little bit easier. Usually the derivative works a little bit easier than what we've been doing. The algebra works a little bit easier most of the time.
I moved the thing on, so I got it.
Which one?
And I did the denominator right for quotient. I know.
So for this one, I never saw memorize.
This is fine.
This is the denominator.
But since this is 0 times this, it's all good with 0.
It just doesn't make sense. But I just said this is
Or this,
algebra.
well, you're using it. I did it where you wrote this x plus 1 so then they have to be over x plus 1 cubed. What you guys written down is not wrong. But I will also add.
Since it's 1 over some, 0, then it's divided by 2.
These guys don't see it.
You're doing that.
If we take out the square.
Which is fine.
But it's like
But on this one, if you move this up.
Oh, yeah, that's it.
Right up like that, you could just do the power band. You could bring the power down and lower the power.
If you bring it up.
It's a little bit quicker at least. You're gonna end up in the same spot, actually.
Yeah, that makes sense.
since it's like a 1 over, you know.
Of course, you guys need to be checking your work in the back of the books. I know the first couple have the graph there for you to check with, but once you get to a point that there's not a graph, you're welcome to graph it in your calculator. It's what you have to do.
But it's still solving to the bond. Okay, yeah, the plus or minus.
So this is, where does this
Just the ones next to it. Kind of like when we do something that says whatever it was. It only dropped like grade.
Well, you could just move it that like -1 half, and you can just move it that way, so I'll do 1 half and then if you split it.
We hit our 50th assignment. It's crazy.
Well, 50th,
Yeah.
I mean, some handouts you didn't have to do anything for, so.
But like, on the record, this is the 50th assignment.
Sure. Okay, well, fraction equals 0 when the numerator equals 0. So you can set the numerator equal to 0 and solve. And it's undefined when the denominator equals 0. So you can set the denominator equal to 0. If it's how it's undefined. Critical numbers are when the first derivative is 0 or undefined. And it's going to be undefined when you try to divide by that.
Like, how do you want us to answer these? Like, on number 9, is this all you want?
Identify where it's increasing, decreasing. So it just wants you to say it's increasing from where to where and decreasing from where to where.
Okay.
That's all you need. And if you do the line chart, then it should just be right there in front of you.
Are you going down? So that would be decreasing.
I definitely got it.
3.
What'd you do over the weekend, Mr. Townsend? Slept until 7:30? No, that's too late, my bad. 6:30.
I got my flu shot and my COVID booster on Thursday.
Nice.
So then I felt pretty bad on Friday.
Oh, yeah, because it was a 3-day thing this weekend. Did you do anything Saturday?
Uh-uh.
No? How do you sit around your house for 72 hours?
I like it.
So, for mostly, I'm a little bit confused because isn't this kind of like equations for
Once you get here,
Mm-hmm.
could you just set that equals 0 and then that equals 0 or not?
Because just because this is 0, if this is 3, 0 plus 3 doesn't equal 0.
Okay, so how would I
You
set
need,
that equals?
I was just practicing this one because this one's a little harder. I got a common denominator for these two. So I'm going to multiply the top and the bottom of this one by 2 square root of 16 minus x squared. So then I can write it as one big fraction. And a fraction equals 0 when the numerator equals 0. So that's where I got those. And it's undefined where the denominator equals 0. But I wrote it as one big fraction by getting a common denominator on the left.
So you put that over 1 and then you multiply by...
Yeah, to get a common denominator, this one needs to be multiplied by a 2 and the square root of 16 minus x squared. So if I multiply the top by 2, that's where this 2 came from. If I multiply the top by the square root of 16 minus x squared, and there was already a square root of 16 minus x squared, that gives me a 16 minus x squared.
Okay, so it just...
And then I put them over the common denominator.
Okay, that makes sense. Thank you.
Oh, I thought he was trying to change that inside. The 16 plus x squared. Plus, and then it's, yeah, plus x times.
Well, if they want us to look at the derivative is going to be 1 over 2 times 2x minus 4. Yeah. So then,
So it's x over 2 times 16 minus x squared.
1 over 2.
Oh, and this is just 4 minus x right here. And then x minus 4. X over.
Yeah, I mean, it's
So
It would just be from 2x or
times 2x with the chain rule, would that be on the bottom?
If you get stuck on number 11, you might look at my work for a hint.
mine was decreasing the entire time.
did you come up with 4 critical numbers?
I don't have.
My guess would be that maybe you forgot.
Oh, I see.
So then you just cut the numbers that made it look like it was down all the time.
I simplified 16 is x squared to the square root.
So did you get it by the same derivative?
I don't think so.
Okay, then you should try product of
Oh,
x
it's-
times the square root of x.
Oh, I think I didn't
It's
find
the
the
same
derivative.
thing.
I said but yeah, it's still x times times. I messed up.
I don't think you can rewrite that much. I think you have to do product rule. Product rule to get the derivative, and you're a common denominator, so you can write it as one big fraction. If the numerator equals to 0, you know when your fraction equals 0. If your denominator equals to 0, then you're fine. That can give you 4 critical
At
numbers.
least they're going down the rabbit hole.
I think that makes sense.
Just divide everything by 2.
Wait a minute. The only thing you didn't do is just add them all together. You just need to add them together.
Oh, yeah. This one?
Yes. About it.
Here? Yeah, you could cancel that, and then your common denominator would be 1. Whereas right here, I could divide every term by 2, and it would be the same as what you get. It doesn't really matter, because, I don't know, I don't think that this is any harder to set equal to 0 than solve. And 16 minus 2x squared. And this 1 square root of 16 minus x squared is 2, so it doesn't matter. You divide it out.
How did you get that 2 on the x times negative 2x over 2 times square root of 16 minus x squared?
Here?
Yeah. How do you multiply that by 2? I thought it was like
I did product rule. Derivative of x would be 1 times this left alone, plus x left alone times the derivative of this. So I brought the power down 1/2, lowered the power by 1, moved it to the denominator,
Oh yeah.
and then chain rule, you have to multiply by the derivative of the inside, the minus 2x.
Yeah, yeah. Okay, I thought you were, since you just didn't put down the 1 for the 1/2, that's why I messed up.
Oh, I see. But it's an understood one.
Yeah,
So now.
One other interesting thing about this number 11, I don't know if any of y'all graphed this, but like if you try a number to the right of 4, the critical number, if you try plugging 5 into this, you try to take the square root of a negative number, which we call imaginary, and imaginary doesn't show up on a graph. So if you actually graph that function in your calculator, it stops after x equals 4.
Crazy.
That's why I put an x there. Yeah, Grace.
On number 11 for that, why does the 32 become negative? Oh, you brought it over.
Yeah, if I'm trying to figure out where the first derivative equals 0, I need to know where the numerator equals 0. So I subtracted the 32 over, divided both sides by -4.
This time, I learned a trick of how to square double-digit numbers in my head. Now, granted, I'm not good at it yet, so I can't do it in my head, but I can write it down real quick.
Okay, well, you practice that, and someday you can do it, but that's not fair.
I like to know.
Because he has 4. He has 4.
How do you know the parent function of this?
The thing under the first part.
Okay, so when I look at this, derivative
is negative plus all that bullshit, when you graph the derivative.
That's emotional.
Then the derivative is positive. The derivative is positive.
That's why you put that over one.
So 48,
Yeah,
if it's negative, how does that work? Because the thing is, all that is
How do you get that? Minus 4 x
as long as it has that derivative. You
You
don't know what it's going up, you know what it's going down. But you know
How do you get to the
Oh, so you do have to multiply.
Maybe. What if this is like, what if that bubble graph was like this close, just like the tiniest amount? What you need to think about on this one is, you see how the derivative is negative here? So when the derivative is negative, it should be below the x-axis. When the derivative is positive, it should be above the x-axis. So you should sketch a straight line. It's below the x-axis, hold tilt 2, and then above the x-axis.
I have no idea. Just critical numbers. So
You figured out 11?
I did. I had the
Got to do plus and minus.
You took the.
That threw me off.
Oh, that's a big one.
Here too?
I forgot to do general.
That's a big one too. Honestly, if you just never forgot the stuff you'd already learned, calculus is pretty easy. But
Yeah.
there's just so much stuff.
I feel good about the calculus usually, and then it's always just the algebra that.
Oh, well, yeah, that's, yeah.
Forget to do like little.
Lots and lots and lots of practice.
Little stuff.
2 times 16 is 30. It goes right there. 2 times negative x squared is negative 2x squared. Negative 2x squared minus 2x squared.
Five and negative 5.
Like negative 2 and 2 and then 0.
You put 5 into the first derivative.
Just like almost like that. Distribute out. Again, probably don't have to.
5 and negative 5. Don't even have those on that graph. So I put a big X there just to show the difference.
So negative 6 is in either and negative.
Critical numbers are the only places where it could change direction.
So it just stays there.
And you graph it in calculator to the left of negative 4 doesn't exist, and to the right of positive 4 doesn't exist.
Oh, you just didn't show it.
Yeah, just send it. So it'd be.
Okay, they graph F for you, and they want you to graph F prime.
I like your belts.
It's the same belt I always wear.
Well, I never like looked down that far. No.
Okay, I've had several questions about 77, so even if you're not there, you might want to follow along for just a second. 77 gives you a picture of what F looks like and wants you to estimate what F prime looks like. So what you have to realize is that when the graph is going down, when the graph is decreasing, the derivative is negative. And negative means below the x-axis. And then when the function's increasing, the first derivative is positive. And so if you're graphing that, positive is above the x-axis. That's what they want you to sketch. and that's it. It can't be super accurate. That one's okay, but the next one's a little more of an estimate.
I'm getting it. My point is, if you have what's that? Like X value negative 2, the Y value should be zero. So this it's not. So maybe we can't do what I said.
Do you still have your work from number like 11?
How we did it? Yeah. Not too many do that unless we keep it on.
Can I ask you a question about 78?
Okay.
So, we know that these are like the critical numbers. So then we put together an equation like x times x plus 2 times x minus 2. Is that how we're supposed to find the equation when we just get rid of that? Is that like the correct way to solve this?
No, you're doing way too much.
Okay.
78.
You seen 77?
Okay, you're trying to graph the derivative.
Yeah.
So, from negative infinity to about negative 1, you see how the graph's going down, which means the derivative is negative.
Because Y doesn't matter.
You know, we don't know what it's going up to or down to, but we know when it's increasing.
Shifts to the right, so.
So your derivative should be below the x-axis, because that's negative, and above the x-axis, below the x-axis, above the x-axis. Decreasing, increasing, decreasing, increasing. Means that the derivative is negative, positive, negative, positive.
So then,
That's why you
guys,
make minus
you need to
one,
do
so
the
it goes
line thing first then?
No, it wants you to make, it wants you to actually make like a,
minus one squared. Yeah, so minus one.
Okay.
so the first part is decreasing until x equals 1. So if the function's decreasing, the derivative is negative. Negative is below the x-axis. And then
Oh,
it's,
okay, I get it, yeah.
and then it's increasing, so it's above the x-axis. And then it's decreasing again, so it's below the x-axis.
So it's just very rough.
Yeah, you don't know what this is going up to or down to. But if we know when it's going up and when it's going down, we can have a pretty good sketch of what the derivative is.
That makes a lot of sense.
And then at 0, then it goes below that. Do that.
Well, maybe this isn't so straight. Maybe this starts to like curve back, so then at 0 it can start being under again.
Okay. I did this one.
You see how the function's decreasing?
It's too wide.
So for the derivative to be negative,
Like,
Kind of like,
it's supposed to go to zero.
the derivative is
I'm just supposed to.
So this would be like this, increasing, decreasing.
when you put it below the x-axis.
What was after that second question?
For me, it looks like
It seems like you said whenever like
negative,
when
positive, negative,
the
positive.
derivative is decreasing below the x-axis.
So it's negative until we got negative 1, and it's positive.
Yeah, that's imaginary.
It'd be like that.
Let me try to write it a different way.
That's good.
Where is it? You just gotta connect.
Yeah.
But I thought since
Like it's one function, it's like one curve. Why don't you make this like, where's your x-axis?
Just call it
Instead of this little piece, this one, maybe like make it.
So then it can be negative here.
Isn't it from Star Wars 5? Star Wars.
Yes, that's
So
right.
whenever it's
One of the swords.
like negative, then just go like this, the negative on the thing, kind of be below the x-axis, and then just positive, that would be above.
Okay, I'm gonna write number 78 in a slightly different way, because I think it might help y'all see. If you thought of 78 in a line chart, this is the function. The function's going down, up, down, up. When the function is decreasing, the derivative is going to be what?
Or 0.
Okay, negative, which is the same thing as less than 0. So the derivative needs to be negative from negative infinity to negative 1, and negative from 0 to 1. I don't know, below the x-axis. When the function's increasing, the derivative is positive, and so if you're trying to graph the derivative, for it to be positive during those values, it has to be above the x-axis. So something like that. It's not going to be super accurate. I don't know how far, like I don't know if this barely goes up. I just know it's positive, so I know it's above the x-axis. I don't know if it goes way up, but this is a pretty good estimate. When the function's decreasing, the first derivative's negative. Decreasing, negative. Negative means below the x-axis. When the function's increasing, the first derivative is positive. And positive means above the x-axis. And all of this should be connected. This shouldn't be like here and then jumps up instantly. Like these need to be connected. So this is what I was saying about turning around here. You need to come back so that at x equals 0, it can go to be negative. Your answer does not have to look exactly like that, but it does have to be above the x-axis at the right times and below the x-axis at the right times.
Can you show your work for 77 real quick? Just so double check my work.
Decreasing below the x-axis, increasing above the x-axis.
Since it's increasing, and then you put it underneath the x-axis, and then since that's increasing, it's above. Now you don't have to find the equation. I thought that'd be easy. This is
Aren't necessarily like the extremes, it's just whenever a direction change happens from negative to positive.
crazy.
Critical numbers are when the first derivative is 0 or under.
You're just telling me.
Often the max or min, but not necessarily.
So it's whenever the derivative is
It's a lot easier to find an equation.
yeah, the pinch line would just be straight across.
Like a
It's
relative max
78
is
if I
like
said it
this.
that way.
So at the top of that derivative here, the slope of that is
Alright, but I don't
That
need
makes a
it.
lot.
so those critical numbers usually end up being maxes or min, but not always.
So for 1 and I, there would be some critical numbers since the tangent line will always be.
Sam and Riley did. I didn't pay attention to that class.
Then the graph was
He has a twin, but doesn't look anything like it.
Sounds like there's a middle.
Yeah, so the graph would probably be similar to that. Okay, that makes sense.
To show that it goes in both directions.
Negative, positive there. Then positive to negative there, but I don't know.
Because it's increasing 0. It's kind of like double check. It's like x cubed where it goes up, it's 0 for an instant, but then it keeps going up. So x cubed doesn't Well, x equals 1 looks like a critical number.
So that is a critical number.
It's still it's a critical number if it makes the first derivative 0 or undefined. Now that doesn't mean it's a maximum min. This is increasing, then 0, and then increasing. So it's not a maximum, but it's still a critical number.
Yeah. You draw the derivative of the graph.
So look, on this, on 70, what I just said.
He said sketchy.
You see this? This is the original thing. Whenever it's decreasing, it's the derivative half to be less than 0. Remember that this slope here, the derivative has to be greater than 0.
How's your book?
It only changed
Good book?
anytime below the x-axis,
Hope it gets better.
it's negative.
Unless it's a history book, because then it probably doesn't get better.
You just do the same thing.
Why did they just put 91? So extra.
No, because remember, if it's below the line, it's decreasing. If it's below that x-axis,
If I do it exactly like you did, what are you after?
Don't worry about it.
no, but this is the graph. That's just a regular graph.
Okay, so you see how this is decreasing? Then you can flip it to the other side.
So
You
that's
see how this is like increasing? Then you flip it to the other side. No, and then you see how this is.
Yeah, it's really bad.
The teacher cooked and something.
Oh, it's ID, not it's one.
Bro, that's shaggy.
Wait,
Yeah, I wanna
so we just move
You flip everything to the other side.
go that way.
but, so it's probably like political science,
Exactly.
student
Whenever
affairs.
we hit 0, it's
Yeah, but no, don't go to 0.
Sometimes.
You see how it does a little loop
I just don't think it's myself to it.
before 0. There's 2 loops, so there's 2 loops.
That's like, but I wouldn't be impossible.
the slope starts going down. Then it's positive.
No. You tripping. You're tripping right now.
It goes back to it goes back to 0. It goes back to 0.
You accidentally put salt in when you put the sugar.
Kinda sounds like
No.
it could be good, but
Oh,
I
I
think it's
did
just
it.
because I watch sports.
Wait, hold on.
So I don't want it to fool me like that, you know?
Replace the sugar with sugar.
You know when you cook it, it's like you're trying to make cookies, but you accidentally put too much salt because you thought it was sugar.
Negative E. I did that one time. It was bad.
Can't remember.
I did.
And then once we get 1, it's a positive slope as well.
Yeah.
So go up that axis. It was like,
You know, except it goes up beginning of the end. I've seen nothing do that all the time. Yeah.
It's not like sad, so it's really good. Yeah. Also, I'm doing
Yeah, 90I. 90I, 90 double I, 90 triple I, 90I.
yeah, 90-1, 90-.
Yeah, that'd be fun. I don't know.
Oh, so we did some four problems.
Yeah, but they're all the same.
Mine.
How do you use it?
Yeah, but we had a brain meeting. Yeah, I just think
Identify the number.
When it's decreasing.
Identify the open intervals.
Oh, Christian?
Huh? Huh?
Nothing.
Okay.
Oh, this is actually easy if you have the graph. So,
I'm wondering if we're allowed to.
identify the critical numbers.
For this one,
Well, there's no critical numbers in this one. This thing is just straight.
Yeah, there's no.
Identify the open interval? I don't even know what that means, so I don't think so.
From 1 through 11.
Oh, is it?
Yeah, is that?
So infinity to infinity is increasing.
No, that's fine.
What is, this doesn't have critical numbers, does it? It doesn't change.
Is there anywhere where the derivative is 0 or unsigned?
2?
Yeah, there's critical number.
Oh, it's just like one of those things where I keep going.
Aren't you supposed to graph a function or something?
What's that function?
You're trying to graph f given n prime.
Use a graph, let it go to critical number, that's a 2. That's it? Yeah. So B and then open interval, well, everything is increasing, infinity to infinity, right?
On the function or the derivative? On the derivative, it's increasing the whole time.
Crap, so we gotta work backwards? How do you do that?
Well, if the derivative's negative, the function is,
Positive. No, decreasing.
if the derivative is positive, the function is. So you know it's decreasing from negative infinity to 2 and increasing from 3 to infinity.
Whoa.
It might be, but just a coincidence.
Decreasing from negative infinity to increasing. Determine whether f has a relative maximum. Yeah, it has an interval.
Alright guys, we've got about 8 minutes, and this would be the time where I would think we'd need to move on, but 8 minutes, we're not gonna really put a dent in the other handouts. So, y'all need to make sure you don't lose those. That'll be one of the first things you look at next class.
Take a picture of this.
You still got 8 minutes, so if you're not finished, you should keep going. And you can see for your homework, if you didn't finish 50, you need to finish 50. I have all of these worked out on the website. So if you need help with any, you can get some help that way. And I want that turned into Google Classroom before next class. There's no reason to still be working on it after Wednesday. So I will put that in Google Classroom right now, so those of you that want to get it turned in can.
It's decreasing in the thing, and it's.
What?
It's increasing in the main thing. In the unprimed in the unprimed f, how do I say that? In the original function. Okay, so it's increasing from negative infinity to 0.5.
Yeah. And then open the so how you do that? Actually, no, that wouldn't make sense at all.
Oh, it just means that at 0.5 it crosses the threshold thing. It's still increasing. For what? So it's decreasing?
Okay, that is now in Google Classroom. So those of you that are finished, you've got 6 minutes. You might as well turn that in to Google Classroom. Otherwise, make sure you do that between now and Wednesday.
I get it. Yeah, I think we should. We figured out how to do this part. With the hours. So this is the prime, F prime, right? The lab. And we're trying to find everything backwards. Yeah.
So that's just like, that's the last one. It's like we have this.
Yeah, and then, so we see the change of it too, across, there's 0. So that's our SPA. And then so I'm increasing F, not F prime.
But it shouldn't work very well.
So like you said, do the opposite.
This was just
Yeah,
like,
get rid of it.
most of it's we split into 2 groups. Our group can do it as well, but
Yeah, and then the minimum is 2.